So imagine trying to perfectly align two microscopic mirrors while you're driving, I don't know, 100 miles an hour. Oh, and those mirrors are completely smeared with fingerprint grease.
That sounds like an absolute nightmare.
Right, but that is essentially the risk happening inside the physical backbone of the internet. Like every single time a tech plugs in a dirty fiber optic cable.
Yeah, and when those microscopic mirrors, when they don't perfectly align, light scatters.
Which means data drops.
Exactly.
Yeah.
I mean, it's wild to think that our entire modern digital life, your streaming, high-frequency stock trading, massive cloud networks, it can all be completely crippled by a smudge of oil that's just a fraction of a millimeter wide.
Which is exactly why we are doing a deep dive into the microscopic world of internet reliability today. We're looking at a really fascinating guide by TMG Test Equipment covering the VIAVI FiberChek Probe.
A very cool piece of gear.
It really is. And our mission today is to figure out why human eyesight is, well, no longer good enough to maintain these networks, and how automating these tiny inspections prevents massive, costly outages.
Well, the golden rule in this industry is inspect before you connect, right? Universally known as IBYC.
IBYC.
Got it.
It sounds simple, but ignoring it is actually one of the leading causes of fiber network faults globally. See, I have to challenge the premise here a bit. I mean, we've been building critical infrastructure for centuries using human judgment. So why is a technician's visual check suddenly such a massive liability? Are they just, getting lazy on the job?
No, not laziness at all. It's physics. When we talk about fiber optics, we're talking about shooting photons of light down a glass core that is, it's smaller than a human hair.
Wow, okay.
Yeah, so when two cables connect, their ends are physically pressed tightly together. If there is even a microscopic speck of dirt between them, it creates an air gap.
And that blocks the light.
Well, worse. The light hits that gap and actually bounces back toward the source. It's a phenomenon called back reflection. It severely degrades the signal.
Oh, so the dirt isn't just blocking the light like a shadow, it's acting like a rogue mirror bouncing the data backward.
Exactly. And because those glass ends are compressed together, that speck of hard dirt can physically scratch and, permanently pit the glass core.
Oh, man.
Yeah, so you don't just have a bad, slow connection, you have permanently destroyed the hardware. And this happens frequently because technicians are under intense time pressure.
Which leads to skipped inspections?
Right, or errors like reusing a dirty inspection tip, which basically just stamps contamination from one cable onto a perfectly clean one.
Like double dipping.
Basically, yeah.
Okay.
And they also have to worry about both halves of the connection. So the sources mentioned the patch cord ferrule and the bulkhead tip.
Okay, wait. For those of us who don't spend our weekends inside data centers, what are we actually looking at there?
So think of the ferrule as the rigid protective tube at the end of the cable that holds that fragile exposed glass fiber. And the bulkhead is the socket it plugs into on the server rack or patch panel.
Oh, I see.
A very common error is a tech inspecting the cable's ferrule, seeing it's clean, and then blindly plugging it into a dirty bulkhead.
Oh, no. So they've just cross-contaminated both sides.
And ruined the connection, yeah.
Which brings us to the technological fix, the VIAVI FiberChek Probe. It's a handheld microscope, right? It operates entirely on its own without needing a bulky laptop on site.
Exactly.
But rather than just reading the instruction manual, I want to know what's actually happening under the hood. Like, how does a tool like this completely remove the human guessing game?
Well, it relies on computational metrology.
Yeah.
So instead of a technician squinting through a lens and subjectively deciding, yeah, that looks clean enough, they just insert the ferrule directly into the tip of the probe.
Okay, and then what?
They press a trigger, the device autofocuses, and its onboard image recognition software takes over.
So it's scanning the image itself. What is it comparing that image against?
The software physically measures the pixel radius of any scratches, pits, or smudges against strict IEC 61300-3335 international standards.
That's quite a mouthful.
It is,
Huh.
but basically it calculates exactly how close that microscopic debris is to the central core where the light travels.
I see.
If a scratch is outside the critical zone, it passes. If it crosses the threshold, it fails and tells the tech to clean it. And then they just reinspect.
So that completely eliminates the subjectivity. You don't have two technicians arguing over whether a smudge is dangerous anymore because the algorithm just says, this scratch is 3 microns wide and violates the international standard.
Right. It's a binary pass or fail right on the screen.
And that objective pass or fail is what allows this entire process to scale up to global infrastructure. Because the probe has built-in Wi-Fi and Bluetooth, right?
Yeah, so every single scan syncs directly to a mobile device.
Let me guess this is about compliance. Like, if you're building a massive project, you need unassailable proof you didn't cut corners.
It's heavily mandated, yeah. Take the NBN rollouts here in Australia.
The National Broadband Network.
Right. Registered cablers operate under strict telecommunications rules and can be audited by the ACMA.
The Australian Communications and Media Authority.
Exactly. And by syncing these automated results, you instantly generate an unalterable, time-stamped digital record for every single connection.
Wow. So you're turning an invisible, microscopic, and highly subjective visual check into hard, verifiable data.
It is a profound philosophical shift, really.
It is. We are no longer relying on human estimation to build the internet. We're relying on automated computational metrology to guarantee that the physical backbone actually functions.
It shifts the entire burden of proof from the flaws of the human eye to an unwavering international standard.
It really highlights how fragile our digital world is at its most foundational layer. I mean, we've replaced human eyes with automated microscopic sentinels just to keep the lights on.
We really have.
But that actually leaves me with a lingering thought.
Okay, what's that?
If a single microscopic speck of dirt can bring down a modern data center, and our global networks are only getting denser, handling exponentially more data, what happens next? Will we eventually reach a point of such insane complexity that we need AI just to inspect the tools that are inspecting the fiber?